Hey everyone, you should have completed exit ticket one by now. And here's the next bit of our electrostatics presentation. Moving on to some fundamental rules of electricity. Most basic rule is what happens between the positive and negative charges. Similar to magnetism, our like charges will repel and unlike charges will attract. With magnetism, the like poles will repel and unlike poles will attract. So, bottom line is if we have positive charge, like a proton, it'll repel another proton, but it will attract a negatively charged electron. And the same goes for the electron. Electrons repel electrons, but attract protons. Here's a little chart just to show you a picture of this interaction between our positive and negative charges, attraction between unlike, repulsion between like charges. Another basic rule of electricity you hopefully already know from basic science in middle school or even chemistry. Another rule of electrostatics that I like to think of as a fundamental rule is the rule of conservation of charge. Just like with energy or momentum, electric charge has a conservation law, meaning that within a system, you cannot gain or lose charge. Now, you can move it around, transfer charge from one place to another or from one object to another, but the total amount of charge is always the same. So you could say that in other words with the statement I have here. The net change, I'm sorry, that should say the net change of charge of a system is always zero. I'll fix that for your presentation before I upload it. So if we have a total of, let's say, 3 coulombs over here and 2 coulombs over there, that's a total of 5 coulombs. No matter what you do, you can spread that charge around, but it's always going to total the same 5 coulombs. And then the third rule of electricity that, these are just my 3 rules. They're not in a book anywhere. But the third rule of electricity is that as we move these charges around, it's really only the electrons that move. So the negative charges are the only types of charge that actually do the transferring. You have to think about the structure of an atom to understand this. You have the protons and the neutrons locked up in the nucleus of an atom. It's extremely difficult to remove a proton from an atom. That's what an atom bomb does. That's the amount of energy required to extract a proton. Electrons, on the other hand, they're orbiting on the outer shell of atoms, and they can very easily flow and transfer between objects. So again, charge is conserved, but it's only the negative electrons that do the moving in order to have this charge move. Here again is a picture example of the conservation of charge. We have, let's say, -4 coulombs here with 0 coulombs on this sphere. If we touch this negative object to this neutral sphere, well, maybe some electrons jump over, and now they're each 2 coulombs, but still a total of -4, just like we started. So this is kind of a summary of these first 2 videos here, this ion slide. Ion is the term for any charged object. That is either an object gains electrons or it loses electrons. It is then electrically charged, and it is called an ion. Once again, the protons are our positive charges, and the electrons give us the negative charge. Each of these subatomic particles have the elementary charge equivalent to 1.6 times 10 to the negative 19 coulombs. You just put a negative sign in the beginning if you're dealing with the electron, positive for the proton. And again, only the electrons are transferred between the atoms and molecules due to the nature of the structure of the atom. This is the end of the second video. You can take a look at exit ticket number 2, and I'll see you in the next one.